All right, this is Mrs. McKennis here, and there was a request from our class to do page 119, question number 20, which is a velocity application. So our story goes, the displacement in meters of a particle moving in a straight line is given by that function, where t is measured in seconds. Find the average velocity over each time interval. So what that means for part A, part 1, is for the average velocity over the time interval. That means that we want to find what the y-coordinate is at 3, and we want to find what the y-coordinate is at 4. So you could certainly go into your home screen and you could type all of those values in, but my suggestion would actually be to go to your y equals screen, drop your function into your y equals screen, and then just create a table, and it's much faster to input multiple x values at the same time. So when we input the value of 3, we're left with the y value of 3. When we input the value of 4, we're left with the output of 2. So an average velocity is the fancy name for the slope of the secant line, which is just an old-fashioned slope. So we're going to subtract y minus y over x minus x. I'm going to go left minus right. So 3 minus 2 over 3 minus 4. So that is 1 over negative 1, or negative 1 for our first average velocity. For the second example, we are finding the average velocity from 3.5 to 4. So 3.5 is my first x value. 4 is my next x value. So 3.5 gives us a y-coordinate of 2.25. 2.25. And we know from earlier our value of y at 4 is 2. So again, we are going to find slope of our secant line, which is the same as the average velocity. So I'm going to go left minus right again. 2.25 minus 2 over 3 minus 4. So we are left with 0.25 divided by negative 1, so that is negative 0.25. And I think you get the idea from here for questions numbers part A, part 3, and 4. You're going to work those the same exact way. So I'm going to skip over those, and I'm going to jump ahead to question letter B. Find the instantaneous velocity when time equals 4. When we were studying this exact same type of problem back in section 2.1, we used the calculator and the table feature. But now we know how to evaluate instantaneous velocity using our definition of the slope of a tangent line, which is also called the definition of a derivative. So I am actually going to use, to find my instantaneous velocity, I am going to use the limit as h approaches 0 of f of a plus h minus f of a all over h. And we are looking specifically at time equals 4. And we already know that the y-coordinate when x is 4 is going to be 2. Okay, so the first thing I'm going to do here, now I'm not using this to find any other time values. If I was, I would actually evaluate this whole limit here with a in it and create a formula so that I could substitute any time values that I wanted. But since I'm only going to be doing this for time equals 4, I'm actually going to replace a with 4. So we have the limit as h approaches 0 of f of 4 plus h minus f of 4 all over h. And now I will substitute in 4 plus h into my function. So you'll recall from the beginning, my function is actually, I'm going to rewrite this over here. So my function is t squared minus 8t plus 18. So I'm going to have 4 plus h quantity squared minus 8 times 4 plus h plus 18. This is the front half. For the back half, I would be substituting in 4 into that function, but I already know that that output is 2. And this is all over an h. And now we're going to simplify this expression. So 4 plus h squared is 16 plus 18 plus 8h, plus h squared minus 32 minus 8h plus 18 minus 2. And that is all over an h. Okay, so if we try cleaning this up a little bit, give me just 1 second here. Okay, I'm so sorry about that. Had a little interruption there. Okay, so where were we at? Oh, we are adding up all of our terms. Okay, so let's go ahead and add up our like terms. So we're going to add 16. We're going to add 18 minus 2, that's 16. So 16 plus 16 is 32. Minus 32, which is 0. So all of my constant terms are adding up to 0. Remember, that's always going to happen with these problems. If it doesn't happen, you know to look back and see if there is something that you miss. So then we've got 8h minus 8h. Oh, those are actually going to cancel. And I'm left with h squared over h, which leaves me with just the function h. And now I am substituting 0 in for h, which leaves me with 0. So at time equals 4, we are seeing the slope of 0. And my question is asking us to find the instantaneous velocity, and that is a good stopping point for us. Thank you so much for listening, and that would represent our instantaneous velocity.